Welcome to StudyBase. Have you ever seen one of these maps with weird squiggly lines? That's a topographic map. And guess what? It can help us predict floods, build safer roads, and even help farmers grow better crops. Today, I will show you how to use topographic maps to solve real-life problems. Let's start with the basics. Topographic maps show us the shape of the land. They use contour lines to show height or elevation. Each line connects points that are the same height. When the lines are close together, it means the shape of the land is steep. When they are far apart, it means the land is flat. This helps us to understand the land without even seeing it in person.
Let's explore the concept of contour lines with a thought experiment. Imagine if you're walking on a small circular island in the ocean and you walk from the shore up to the 2 meter above the shoreline. If you were to walk around the island and stay exactly 2 meters above the shore, you'd be walking on a contour line that represents 2 meters of elevation or height above the sea level. If you move off that line, you are either moving uphill or downhill. If you could walk uphill another 2 meters from your first 2 meter contour line, and if you stay that elevation or height, which is 4 meters above the sea level, while circling the island, then you walked the 4 meter contour line. The vertical change in the elevation or height between these two adjacent or opposite contour lines is called a contour interval, which in this case is 2 meters. But take note, for topographic maps, in most cases, it is 20 meters. If you were to transfer these imaginary lines into a map, you would see 3 lines forming concentric circles that represent 0 meters, which is the seashore or sea level. 2 meters and 4 meters, and your map would look like this, like a bull's eye.
Let's imagine there's a heavy rainfall. Water flows from high-lying areas to low-lying areas. With topographic map, planners can see which areas are at its lowest height. These areas are most likely to flood.
So imagine these are low-lying areas and high-lying areas. They are buildings, and then it is raining. This water flows downhill in a V shape. Here's an example of a mountain that is from high-lying areas to low-lying areas. The water flows from the head of the mountain to the mouth. That's how a river flows from high-lying areas to low-lying areas. Now this is high-lying areas to low-lying areas on a topographic map. It is in V-shaped form. This is the blue line. As you can see, it's coming from high contour lines with big numbers to the lowest, from 1,000 to 880.
So if you are designing a town, you would not put hospitals or schools in low-lying areas. You might also build drainage systems in the right place to direct water away. Building roads in steep areas is quite dangerous and expensive. Engineers use topographic maps to find the best path with a gentle slope. For example, a car going up the hill. It is struggling to drive up the hill, so now it is pushed up the hill. Okay? Because the hill is steep. The driver has now found a gentle slope, and the car is driving safe and free. Let's say you want to connect 2 towns. The straight contour line is the fastest, but it crosses a steep hill. A topographic map can help you find a safer, easier route around the hill.
For example, a hill between 2 towns. These are 2 towns. There's town A and town B. On your left, there's town A and then town B on your right. They need to be connected by a mode of transport, which is a railway or a road. Here's a hill on a topographic map. This is the representation. This is how it will look. It is separated by a railway line.
Farmers use topographic maps to decide where to plant crops and how to irrigate or water them. On steep slopes, water can run off too fast, causing soil erosion. On flat areas, it can be stored and used efficiently. So topographic maps also help design irrigation channels by showing how water will naturally flow. Now, let's test your skills.
This is an example of contour plowing and irrigation that will happen on a farm that is mostly used by these farmers. It is planted in contour. As you can see, the arrows are going in circular, it's centric, and then the grassed waterway, it is where the water is stored to grow the crops. In this challenge activity, you're gonna answer these two questions. Take a pause and think about it, where you would build a school and which areas might flood. These are the suggested answers to the challenge activity. For the first one, in the flat areas near the valley, and then in the second one, the areas around the valley and the cliff.
So now you know topographic maps are more than just lines, but they are life-saving tools used by engineers, farmers, and disaster management teams. Next time you see one, try to figure out this.
These are the 3 important skills to remember. You must firstly take note of where is the high ground, what could flood, what is the best place to build at.
Study mates, thank you for watching our YouTube channel. Stay tuned for more. See you next time.